Hello, everybody. That's the 22nd webinar. This time it's going to be about object-oriented programming, like most of the previous webinars. And we've been talking about this subject for over 2 years. And in every single webinar, I'm trying to focus your attention. I'm trying to ask you to pay attention to that's the 22nd to pay attention to what your objects are and how much they encapsulate and how much they don't encapsulate. Today we'll talk about the idea which I call naked data, which is exactly about the same, about encapsulation and about what is an object and how that object is managing the data which is inside it, but from a little bit different angle, which may be helpful for you to understand what encapsulation means. I will show you first of all the question which I asked on a few seminars, which is kind of interesting. Let me share the screen with you so you can see the question. So here it is. It's a question from the next book I'm writing right now, not the second volume of Elegant Objects, but the next one, which is going to be the third one, which will contain questions about object-oriented programming and answers. It's going to be quite interesting format, which I'm sure will help readers, you guys, understand object-oriented programming from a practical perspective, because previous 2 volumes, they were kind of, also practical, but I've heard a lot of complaints about that discussions being quite theoretical and not really practical. So this time, the third volume will be really practical and all about questions. So here's an example. This is question number 8 from that book. As you can see, there are 2 pieces of code. The first one is it's both Java, the standard Java libraries. The first one is the URI, which you create, you encapsulate the URI, and then you get the port out of the object U. And then the second object, which is of type label, and which is of type, sorry, there's a typo. So it has to be point. So it's of type point, where you encapsulate the coordinates of x and y, and then you get x. So the question is, in both cases, we have these like methods which start their names with get. And the question is, which one of them is actually a getter, which we discussed from so many times that getters are actually a really bad idea in object-oriented programming, and they have to be completely we have to stay away from them as much as possible. So the getters are really bad things because they violate the encapsulation idea. They allow other objects to get access to the data which our object encapsulate. So in both cases, it looks like this script, which is right in front of us, can actually get access to something from inside URI and then something from inside. And we know that getters are bad. So, but the question here of which methods here are actually getters. This get port, is it a getter? Is get x, is it a getter? And the question is kind of tricky because we cannot really tell by the name get. We cannot just say that both of them are getters just because the name is get. You can clearly see the difference, and the right answer here for this question is that only the get port is only the get x is actually a getter, and the get port is not a getter because it doesn't return the state, the encapsulated state of a URI. Instead, it builds something for us, it creates the port, and then returns it. So in this case, get port is a behavior, while get x is a direct access to the state. So in any object, we have 2 basic things. The first one is a state, which means the attributes which the object encapsulates. And the second thing is the behavior, is a collection of methods which we can use on this object in order to in order to get some behavior, in order to force that object to work for us. So getters, they look like behavior, they look like they're from the second part, they're from the second portion, but in reality, they are just helping us to get access to the first part, to the state. And that's what's so wrong about it. So an object which exposes state, which lets other objects to get access to state, is a bad object. So here is the question is, the answer is 2, because in the first case, it's not really a state, because the real state of the URI object is this one. This is the state. So this encapsulated string, this encapsulated address of the web page is the state. While the get port, no matter how it works, it extracts this port from the URI, or it stores it in the attribute, or it doesn't really matter what happens inside. What matters is that it's not the state. So the port of the URI is not its state. Its state is this line, this string. While in this case, the X is clearly this number, which is encapsulated, which exactly is a state of the point. But I can hear you. I can hear your questions now. That how do I know what happens inside the URI, and how do I know what happens inside the point? And that's a good question. We don't know exactly, because it depends on the JDK. We don't know in this question. We don't know exactly what's inside, and that's why the answer is not so strict. So we cannot say for sure that get port is not a getter, and get X is actually a getter. So it's a gray area. It's a kind of thin line between what's happening. But what's important is that it's really bad for an object to expose a state, and it's really good to expose a behavior. And that's a big difference. Let's take a look at another question, the second one, again from the same book, question number 9. So look at the first example, which again from Java. So it's a file. We create a file, and then we call get read only, which returns the read only attribute of the file and places it in the Boolean variable. And then we do set read only, so we set it back. Again, pay attention to the names, get and set. Clearly look like getters and setters. And then the second example, we use the class button from Java AWT, and then we get label from that button, and then we set label back. Which pair of methods, and look at their names, get and set in both cases. So which pair of methods is actually a pair of setters and getters? Again, it depends on what's going on inside that methods. We don't know for sure. We have what we have. We're just looking at the surface. We're just looking at how it's used, and we can't really tell, but we can assume. So in this case, in the first scenario, we can understand that when we do get read only, then most probably this read only attribute is not really an attribute of the file. It's something which is located on the file system. So in order this method to work, it has to go to the file system and retrieve that data from there. So that this object F has to work with some other entity which it represents, the real file on the file system, in order to return the value. And that's why we call it behavior. So it's not getters and setters which give us access to the state of an object, it's behavior of an object. And in this case as well, so we get and set. So the only thing is confusing is the name get and set. So probably the designers of this class, they were not really they didn't pick the right names, I think, because they confused the reader by this get and set name. Because in most of the Java world, we used to see this get and set prefixes when we face the setters and getters situation. While in this case, this is a perfect example of getters and setters, because this label, it's definitely an attribute inside the button. So when we say get label, we definitely retrieve the attribute from the button, and we definitely set it back. So this is a mutable class button, and this is an immutable class file. So class file is immutable according to documentation, and I also agree with that, because all these things are just behavior. They just transfer the information through and doesn't place it in the state. While here in the button, it's mutable class, and we are actually changing the state by saying set label. So that's the big difference. So the point is, setters are bad and behavior is good. But it's not it. It's not what I wanted to say. It's just a start. So I'm just reminding. I'm trying to remind you so that you remember the main point. The main problem is that the data which goes out of the class is a problem. And let me return. Let me get back to this one. Yeah. So the main problem is that when the data jumps out of an object and then becomes available to everybody, it is a problem. So again, think about this URI class. We encapsulate the URI, and we encapsulate this string with the Google or whatever, and then we say get port. And when the port is out, which is number 80 in this case, so this number 80 is out because this is the port number for HTTP protocol. So the number 80 is out. Now it becomes just a number for us. It doesn't have any semantic anymore. It's just a number 80. So the user, the client, who will get that number 80, will not know, will not see any restrictions, will not know any specifics about that number. For example, the protocols, all the TCP stack of protocols, they start from 0 and they go up to 65,535. So this is the range of protocols. But when the number 80 is going out, it's just an integer with the range of possible values way bigger. It goes to negative numbers, it goes to really big positive numbers, and the client who gets the number doesn't know the semantic of it anymore. Well, as long as it's called port, then maybe the client will know that it's a TCP port. But if you transfer that number further and further, you can forget that, and you will not know it, and you cannot apply any restrictions to it. So the moment the data escapes an object, they lose the semantic. Of course, you can wrap that port in the specific class port. You can create a specific class TCP port, and then you return the TCP port, which will allow the user, the client, to change that value only in specific range. But in this case, again, we will not know that TCP that class port will not know that much the URI which it came from. So it will not know, for example, that it's I don't know, for example, that for the URI that the specific port numbers are not in the entire range. So you cannot put the number, I don't know, number 1 there or number 10. There has to be only specific numbers. While in general, TCP port is more generic. Again, you can narrow it down by creating a more specific class, but it's not done. In case of URI, it's not done. All these changes are not there. It's just plain integer, the plain number which escapes an object and becomes available to everybody. And that's what makes the design of the URI not really perfect. So my point, that's what I'm trying to say, is that in general, that's my idea, is that in general, you have to avoid situations where your objects expose data to other objects which stay on the same level with them. And I'll show you the diagram to explain this same level statement. Let me share another piece of my screen. 1 second. Yeah, here's the diagram I created. So look at this diagram. On the left side, we see the right usage, and on the right side, you see the wrong usage of the URI class. So let's start with the right side. So here's the class, here's the object of class URI, and then the method get port. And then let's say we have a page which wants to load the content of this URI. So this is how it works. So let's say they stay on the same level, and then in the page, in the class page, you have the method content, and you provide the URI, and then you get the HTML. from this method content. So the page class will definitely need to get the port out of URI in order to create a TCP connection, in order to open that port, in order to open the socket and then read the content, to do all this HTTP communication. So in order to achieve that, it will be necessary to retrieve this get port from the URI. That's one example. And this is wrong because they stay on the same level. They stay on the same level. They are independent from each other. And the data which goes through, and they go here, so the number 80 will be flying here. Here's going to be number 80. So this number 80 will be here. It will fly in the air from one object to another object. And that's when it becomes naked. That's when it's not good. The alternative approach, which I think is better, is that we don't allow, we can't do that in Java. It's just theoretical. It's kind of theoretical talk. You can't do it practically in Java, but you can design, you can think like that. So this is a way better approach. When the get port method is only allowed to be called by an object which encapsulates the URI. So in order to use get port, you cannot just get a URI, you can't just get any URI object from somewhere and then get port from it. You need to encapsulate it. So we need to build a bigger object from smaller one in order to start using this data from the smaller one, from smaller objects. So in any case, we need the data. Definitely. We cannot design our objects without methods that actually extract data or generate data or build data. In this case, this get port is not a getter. So we already agreed that getters are evil. It's not a getter. It's actually would be a better name for this method would be just port. So we forget about this get name and we just rename it to port. But still, this port method actually returns the data. Actually returns number 80, and it's still the same problem. This number 80 is moving here, and then this page, this class, makes the decision of what this 80 is. In this case, it will make probably the right decision, but who knows? As long as the data is there, we cannot control it. The URI cannot do anything with this piece of data. It's just number, it's just integer. Like I said, without any range, without any limitations, it's just a plain 4 bytes, which this page can do whatever it wants. The same will happen here, of course. Technically, the same will happen here. But and this number 80 will also, fly here and will also exist somewhere in the air. But this air is safer than this one. That's my point. That's what I'm trying to prove. Well, I can't really prove, but this is the idea. So this horizontal allocation of classes make this code procedural, because there is somebody always here looking at this combination of objects, and there could be somebody else who will also extract that port. So the amount of these arrows will be really unlimited and will be outside of our control. So the URI will definitely not know how many more people, clients, objects, whatever, are also extracting that port. And there will be many of them, thousands of them. Because anytime you need port, you just get the port and do something with it. In this case, in order to use the URI and use that port method actually to extract some data, because you can use URI without extracting the data. It's also possible. You can use it to, for example, you get the URI and then you want to just print it and show it to the user, like, hey, this is my URI. In this case, you don't extract anything. This is the perfect object-oriented way of using this object. But if you want to extract, to ask the object to generate some data for you and get that data out, then it's better to put that extraction process into the safe border of another object. So only this page will do that. If you need somewhere else, you will also encapsulate URI. And you will do it in way less and way smaller amount of places comparing to the situation where you can do it anywhere. So all your usage of URI will be encapsulated in bigger objects. Here in this case, it's a page. And now let's look at the Java code. So here's the wrong example. So we have a class page, and then we have a method content. The URI comes in here, and then we get URI. Okay, we can replace it and put the port here to make it non-getter for sure. So we get the URI port, and then we say, and then we load and return. But this is wrong, because in this case, this URI, like I said before, anybody can do the same, anyone. And it's not good for URI, it's not good for its design. It means that it exposes too much. It makes the data naked. It makes the data too available to so many clients, which will eventually cause problems for maintainability. You will eventually lose control of how many clients you have. In this case, when it's encapsulated, and then we get the port, and then we access that port. In this case, it's safer. And if the language would be better, if it would not be Java, but the more powerful language, then would be nicer to technically restrict that usage and say that only the class which encapsulates URI can use the port. We don't have right now, I don't think we have, well, correct me if I'm wrong, but I don't think we have any language which has that restriction. We have the restriction for inheritance, but we don't have that restriction. But that would be nice to say that, if you want to use URI, the methods you can use is like print me to string or print me to XML or send me over a wire. I don't know, just do something. And then if you want to extract my data, like port, this is actually data, even though it's not my state, but this is the behavior which will generate data for you. In this case, if you need data, and it's not going to be naked data, because I understand that as soon as I give you the port, it's just integer. It's not anymore a port of the URI, it's just number 80. So in this case, I want you to encapsulate that operation. I want you to work with me as your attribute. So this I think is right, this I think is wrong. That's my point. And let me show you one more example before we finish with this point, and then you ask me questions. So I will show you now the example from the second volume of Elegant Objects. This is, by the way, the book. So we have the second volume coming out in approximately 3 weeks. And in that second book, there is an example of, I'll show you just a number of pages now from that book. Of procedural code in a few languages, in Pascal, in C, in Java, and then an object-oriented example of the same algorithm, the same problem to solve, but in an object-oriented way. And the difference between these two pieces, you will see it clearly now. The difference is that in the first case, we have a number of variables, a number of data pieces, which we see and which we operate, which we manage. So we have some objects, but then the data which flies between that objects, they are naked, like in the examples with the URI, and we see them in the script. While in the second example, in an object-oriented one, there will be no variables, no data flying in. There will be only objects. Let me show you. That's the book, page 100 something. Yeah, that's the book. So here's the example of the procedural code. First of all, it's an algorithm. It's a quite simple algorithm, which is guessing a number. First of all, it's in BASIC, a language which probably all of us know, and this is a procedural code, a piece of BASIC language. It's a game or number guessing game. This is really like ugly code. It's not even structured because it has go-to statements and many go-to statements, and it has data. So N is data, T is data, X is data, and it's all data. So it's like 1, 2, 3 variables, 3 pieces of data, and code. Code and data, they stay together, and they're all on the same level. So all these statements and commands or whatever it is in BASIC, they're on the same level. Then the next piece of code, and this is the algorithm, this is a flow chart of this game. So the flow chart is also visible. They're like, rectangles are like statements, and these T, N, X, like variables. It's exactly the same as we've seen just now. Then this algorithm in Pascal. This is the language Pascal, which is also still quite popular. It does exactly the same, and it also has variables. One, you see that they're just declared on top. There's 3 variables which help us to manipulate with the user and do what the user wants. Next example is the C code, not C++, C code. The same story. So we have 1, 2, 3 variables, and we manage them. So the data, they are the naked data. They stay between operations or between objects. If we move lower, we can see Java example of the same code. Not any better. In Java, the same. We also have some objects. We also have some object-oriented so-called code. We have the scanner. We have the system out. It's a writer or whatever it is. We have this again scanner, math, something, and we have variables n, t, x. So the variables, they stay between objects, and we pass them from object to object. And that's what makes this code procedural. So this is the ugly code. This is not how the object-oriented code should look like. And now I'll show you how the object-oriented code should look like, which doesn't have any variables, and it shouldn't have any of them, and the data are not escaping from object to object. They encapsulate. Objects encapsulate data. I'll show you the final one, because the book explains how I get to this final code, but it looks like this. This is the same algorithm, but in an object-oriented way. So we create an object, we instantiate an object, we instantiate another object. This is not really Java syntax, but it's really close. And then we encapsulate, we encapsulate, we encapsulate. So all the data operations, they definitely exist because we need data in order to talk to computers. But all these operations, they happen inside objects. Just in the diagram I showed you before. So when the object diff, for example, wants to this object, it does it, but because this one encapsulates this one. Child and parent, but not in an inheritance way. Forget the inheritance. Inheritance is bad as well, but in a way, in a composition way, in an object composition way. So all we do is that we once encapsulate data here a little bit, but we can remove that as well. So it's all about encapsulation and hiding, and this code looks like that simply because we don't allow objects to give data to each other unless they encapsulate each other. So that's the rule I'm trying to give you, and it's kind of experimental. I don't think I have like real proof for that, but that's what I feel. So if the two objects stay like that and the data goes like that, it's a problem. If it's like this, one object and then a bigger one encapsulates it and the data flies inside, they just exist inside, it's better, it's way better. It makes design more object-oriented, safer, and more robust and more maintainable. That's what I have in mind. Now, probably your questions. I said everything I wanted to say. Yeah, we have a few questions here, so let me read it. Yeah, there's a comment here that the button is not a good example. Probably J button would be a better example. Thanks for that. I'll fix the code. I'm not really an expert in this button, so that's why. Yeah, I'm trying to read. Yeah, so the comment is here that we don't restrict content to use URI. Yeah, right now we don't restrict content to use URI. Of course, in both cases, we need to extract that data from the URI. I mean, to create a TCP socket, in order to open the socket, you need to know the port number. It's inevitable. You just have to do it. We need to do it. So to get this port number, otherwise we will have to put a lot of functionality into the URI and then ask the URI to create the socket for us. It's also possible, maybe it's not a bad idea, but in this case, the URI will be a huge class with like thousands of methods, because it will give us all the possible options to do what to do with the URI. So it's not really the way we want to go, because in that case, we'll have like probably 5 huge objects and that's it. No, we need that data to get out. We need that data to become naked sooner or later. It will happen. But there are 2 different scenarios. The first one is that we give this URI to some content method, and then content method does something with it, and that's it. And there's no connection between these 2 classes, the URI and the page. Another example, another scenario is when the URI will be encapsulated in the page. So the URI becomes a page. So it was a URI with 5 methods, and then it becomes a page with 3 other methods. So it becomes something bigger. It becomes a more powerful entity in the program. It was a smaller entity, and then we created a bigger one on top of it. It's not that just a smaller one gives everything it has to bigger ones. No, smaller one becomes a bigger one by object composition. And if the language would support that and would allow us to prohibit any other usage of this smaller class, of the smaller objects, that would be amazing. So let's say we cannot get the port out of the URI unless we encapsulate it into a bigger entity. That would be amazing, but we don't have that. But every object, another question, every object will exist encapsulated in another object. Yes, exactly, that's my point. So every object has to exist encapsulated in another object, in a bigger one. So smaller into bigger, into bigger, into bigger, and the biggest one is the application by itself. But in software we have right now, it's not the case. We have just one controller, for example, and then 15 different objects. And they don't know about each other. They just exist, and then the controller or something or some script, they just put them together. Take the data from one, take data from another one, and then put some data into another one. So we manage these objects, and they don't know about each other. And that's what's wrong. It shouldn't be like that. There should be no object which gives any data to anybody, not knowing there should be no object which gives data to somebody who is not its encapsulator. Let's put this name here, encapsulator. So we can only give data to encapsulators. It's not quite clear why a page would need to know just the port without the entire URI. Yeah, definitely. It's just an example. So of course, in a real world, the page will need to know more. It will need to know the host name, the URI, the port, host name, the query part, many parts of the URI, and it will basically extract all of that data in order to make a request and retrieve the HTTP protocol and HTTP data. Of course, everything, all of this data. I just picked the port for simplicity. Yeah, and that's another comment. That's right. The last object is application object that will create, which will encapsulate all objects inside it. That's how it should, which will we have in the end. Another question. So you were saying that in the wrong example, it could be like a static method, which we definitely not want. Yeah, I did understand that. So definitely we don't need static methods. Now we're talking about objects now. In Java, it is allowed to use private properties from the same class. Yeah, in Java, we have some restrictions, but they are they're only for inheritance. So they're not for that kind of use. So when an object encapsulates another object, Java doesn't have any keywords or any instruments to protect them against each other, or not to protect, but to allow each other to be friends. I have an article on the blog a few months ago, which is called Can Objects Be Friends? So that's exactly the idea I'm trying to explain now. So these two objects, the smaller one and the bigger one, they have to be friends somehow. And they have to have an ability to communicate more openly than objects that stay together, that stay just in front of each other. So two objects which don't know anything about each other, which don't encapsulate each other, they are not friends. But as soon as you encapsulate, they become friends, and then the bigger one gets access to smaller one way more open and way more friendly than it was before. That would be the good feature in object-oriented world, I guess. That's what I'm trying to tell you. Next one. So is my comment correct? Is this code right? New application, new port, new URL port. Yeah, everything. That's right. So in the example, the question is it correct that the application will have new application and then inside will be new page? and inside will be new URL. So there will be new, of course, like in the example I just showed you. So it's going to be one big, huge new object created by the new operator, and everything else will be there inside, and inside. Yeah, another question: if the URI would be an interface, it's a question about the first part of the webinar when we were discussing what is a getter, what is not a getter, and the question is, what if the URI would be an interface, and how do we know if this get port is a getter or not? We don't know. We definitely don't know, and there is no guarantee that, because if you look at the URI, actually the implementation of URI at least in OpenJDK, then you will see that port is actually an attribute. So technically, it is a state of the URI. No matter what I said before, I said it's a behavior, this get port, but technically it is a state. But it's only because in Java there's no built-in caching possibilities or instruments for calculating something once, and that's it. So in Java you cannot mark a method with somehow tell that these methods should be executed once. That's why the URI is designed the way that you encapsulate the text, and right in the constructor it parses it and breaks it down into parts, and then encapsulates that parts. The port, host name, schema, the query string, all that parts, they go into attributes, and they become the state. So if you look at this get port function method, then it is a getter, but not really, because the real state of this class, of this object, is the full name of the URI, the full address. So what happens inside, how technically it is implemented, it doesn't matter. Whether they calculate, whether they parse it inside the constructor or they parse it on fly. For example, you can design the method get port, which will parse the whole thing on fly, but it's not going to be effective. It's going to be time consuming, because every time you will parse again and again. So you need to somehow to cache it. That's why they do it in the constructor. It's not good, it's bad, it's not object-oriented way to parse something in the constructor, but they do it because of the limitations of Java. Ideally, it would be great to have some methods, get port or port, and then some kind of annotation or whatever, some marker, which will tell the Java machine that don't call it twice, just call it once, and as soon as you get the port, every second call, it's an immutable class, so it's a constant class actually. So every second call, you just get it from heap or whatever, from somewhere. But instead, they're using attributes for caching, which is an ugly way, but that's the only way you can do in Java. So that's why we don't really know, to answer your question, we don't really know whether get port is a getter or not a getter, because we need to look at the implementation, and even after we look at the implementation, we still don't know, because it could be a workaround. So it's a really gray area. It's difficult to say, and that's why it's better well, definitely you have to stay away from getters, like pure getters. So you shouldn't expose your state, never. But even if you give some data out, then think about that principle I'm trying to suggest, the principle of giving your data to encapsulators only to objects which encapsulate. Another question: how would objects from different branches talk to each other? From different branches, I think that we're talking about like branches like packages, or probably, because branch, it seems to me like a Git word, or version control word. But if I understood you right, then you mean that we have two objects from different pieces of code, from different packages, and then how do they gonna talk to each other? The same here, they shouldn't talk to each other. They should encapsulate one another. And once they encapsulate one another, then they start to talk. So they shouldn't be like in model view controller. The controller and the view and the model, they're all equal. They can't be equal. They need to encapsulate one another. Which one will encapsulate another one? That's a separate question. But they shouldn't be they shouldn't be equal, so to speak. They have to be one inside another one, because otherwise it becomes procedural. Otherwise, like I said before, this data, they just fly around from object to object, and they mess everything. They turn everything into the code, which I've seen you like in the basic code, in this flowchart code, where we see variables, we see pieces of data, and we see statements, and how these statements manipulate data. The code it may look clear to you, but it's not object-oriented. So the code I showed you after is definitely object-oriented, and so still Java, but that's how it should be. Yeah, there's a refinement of the question. So the question I just tried to answer, the question was, how would objects from different branches talk to each other, and like models talking to each other. Models talking to each other, I think that it shouldn't happen. The model should not talk to a model. So if you have like, I mean, by models, I think you mean, yeah, there's event layer, controller. That's what I'm saying. Yeah. So by model, people mean real objects which represent things which we manage. For example, a user, a click, or an event, or a table, a cell, a spreadsheet. That real things which these controllers and all the layers are managing. So they shouldn't talk to each other. They need to become bigger objects. They shouldn't talk. They need to become something bigger. And definitely, we don't need to have controllers. So if you have a user, and then an object which represent the user, and then you want to that user to be visible on the page with the profile information. For example, you need to show the picture of that user on the HTML page. Then you just create a bigger object which is called user picture, or just picture, and that picture will encapsulate the user. So the user will be part of the picture, and then the picture will get the data out of the user, and then the picture will behave like a picture. That's what I believe. That's what I think. And then bigger, and then, for example, you need not just a picture, but you need something. Not just a picture, but a balance of the user. And you want to show the balance on the same page. So then you create a user balance, like balance object, and then picture object. And this one encapsulates user, and this one encapsulates user. But there are two objects, and then something else encapsulates them too. So the two of them become a page, or a user page. So there's a user page. Inside user page, we have balance and picture. And inside balance, you have user, and inside picture, you have user. So if you look at it, you will see a big circle, and then smaller circles, smaller, 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 down to the most primitive objects. But no controllers, no layer, no service layers. It's all wrong, I believe. What do we do if the next question, what do we do if we're using a framework that actually requires using of getters and setters? That's a very typical question. I don't know. You just find a better company or a better project. Definitely, we have so many getters and setters everywhere. I was writing code today, and in Java, I just finished it like 2 hours ago, and it was yeah, I was using getters and setters. I mean, I didn't create them, but I had to use them because they were coming from a library which I had to use. So it's inevitable. So if it's some library which you have to use, of course you use it. But if it's your code, if you create the code, then you don't create that mess. You don't create the getters and setters. But yeah, look at this. Look at even the languages. Look at Ruby, for example. I was writing Ruby today as well, and in Ruby we have this accessors. So you just define a class, and then you just declare that you need accessors. And like they just give you getters and setters. I mean, they just define you methods which will help you to catch the process of accessing that attributes. Right in the language. Yeah, it's not even the IDE, which is okay, we can forgive the IDE, but they designed the language that way, and they call it object-oriented language. So what can we say? It's just bad, unfortunately. But we can change something if we stop using these getters and setters, for sure. But not only stop using them, but my point is that we had a discussion about getters and setters a long time ago. Another webinar, you can search for my webinars, you will find that. We were discussing getters and setters for an hour. and I tried to convince you that it's a bad idea. But now my point is that even further, that if you remove getters and setters, it's not all. You still have a problem of naked data. You still have a problem of data. Because even if you don't have getters and setters, if you have just a method port, which is not a getter, but still, it's number 80, it's still a number, which goes somewhere, and then the control is lost. The next question. Where we can see some good example of your vision of object-oriented code, maybe some code on GitHub. Can you share some links? Yeah, definitely. In my GitHub account, you can just find a number of projects which are, well, quite good object-oriented wise. You can look at the Takes framework, Takes, and also look at the Jare project, J-A-R-E. Jare, which is the live system in Java. Live system, it's in production, it's all in Java, and inside it looks quite object-oriented. So it doesn't have getters and setters for sure, and it doesn't have that, more or less, it doesn't have the problem with this naked data. I can't say that all my code is that. Again, it's a really like gray area. You can't really tell what's the, there's no one single easy principle to follow. And it's not so easy to follow it, but try to go that direction. I'm also trying. I just found out that this principle is useful just a few months ago. So, and I'm sharing it with you. So this principle of not allowing any objects to access my to call methods on myself which expose some data. That's the principle. I believe it's useful. Try it yourself and see how it goes. But okay, and definitely forget about getters. So I mean, this is not the subject of the webinar, but you don't need to use them. Okay, we have one more question and we can finish. Yeah, there's a discussion on Gitter going on right now. So we have a Gitter channel, by the way, so you can check it also. We are discussing the object-oriented programming there as well, and you can ask questions there. And there are not so few people, right? I mean, there are many people right now in this channel which actually share that ideas, and some of them really understand them better than myself. So I'm really glad to see that you can jump into the channel, ask a question, and you will get an answer from really people who are object-oriented programmers. So just join us and discuss. We are always there talking about what's good and what's bad for object-oriented programming. There are people listening to us right now, I guess. Yeah, they are, or maybe not. Yeah, I think there are. Okay, so we're finishing. Thanks for that. We just 50 minutes, a little bit short today. So see you soon. It's gonna be the first Wednesday of each month, 11 in the morning Pacific time, San Francisco time. And next time the webinar will be about management. So I'm trying to do programming management. So this time we talk about programming. The next time will be management webinar. And in the months it will be about programming. Okay, guys, thank you very much. See you later. Bye-bye. Thanks for listening.